Okay, Chapter 8 on Access Control List Part 2. Okay, in this chapter, we'll review what we have learned in Chapter 7, that is Standard Access Control List. And then we'll look at Extended Access Control List for IPv4. And followed by IPv6 Access Control List. And finally, we'll look at some of the common ACL problems or errors and how do we troubleshoot them. Okay, Standard ACL. Okay, so we are going to review what we have learned in Chapter 7 on Standard ACL. Okay, if you remember in Chapter 7, we mentioned that ACL consists of a sequential list of permit or deny statement, and the order of the list is important. And this statement is also known as ACE, Access Control Entries. Okay, so, and in Standard ACL, okay, for every single packets, you will examine the packet and decide whether to permit or deny. And you can decide whether you want to examine packet going into an interface or going out of an interface. So for every single packet, for Standard Access Control List, you only examine the source IP address of every single packet for Standard Access Control List. Okay, so how do they decide whether the access control entry match with the source IP address of the packet? We use something called a wildcard. Okay, the wildcard mask is used to determine whether the packets, the source IP address, matches with the rules, whether matches with the access control entries. And then they will decide whether to permit or deny the packets. Okay, so we have a few examples here. The first one, if the wildcard is 0.0.0.0, this would means that I must match every single bits of this IP address, which means I'm only matching for one IP address, 192.168.1.1. So I'm only looking for IP packets with the source IP address equals to 192.168.1.1. Okay, in a second example, if the wildcard is all 255, 255, 255, 255, meaning all the bits are 1, this means that I do not need to check any single bits. All bits are ignore, meaning all packets will be matched because there's no need to check. Okay, so in this case, every single packet will match if my wildcard is all 255. Okay, finally, if the wildcard is 0.0.0.255, okay, this would mean that I only need to match the first three numbers. Only the first three numbers where all the bits are 0 in the wildcard. I need to check for IP address that start with 192.168.1. For the last number, which is, well, the wildcard is 255, this means that this I do not need to check. I don't have to make sure that it's .1, .2 or whatever. I only need to make sure that the first three number is 192.168.1. The last number I can ignore. Okay, so this means that I'm checking for IP address that start with 192.168.1.1 for every single incoming packets. So that's for Standard ACL. Okay, we also went through the three basic principles of access control list. There is one ACL per protocol, one ACL per direction, and one ACL per interface. Okay, this means that for every single interface, let's say this interface G00, if you are only running one protocol, IP version 4, there can be two directions applied on this interface. It can be going in or going out. But there can be only one ACL applied going in, one ACL applied going out. Okay, let's say you are running two protocols, V4 and V6. This would mean that I can have one ACL going in, another ACL also going in. So total 2. So one for V4, one for V6. I can also have two more ACL here. One for V4, one for V6, but they are going out. Okay, so total 4 ACL. So V4, V6 in, V4, V6 out. And let's say you have another interface, G01. This means that you can have a total of 8 ACL. Okay, so you can have V4, V6 going in, V4, V6 going out of G01. So total 8. So these are three basic principles of ACL. there can only be one ACL per protocol, per direction, per interface. Okay, in this chapter, we will look at extended ACL. So just now I mentioned standard ACL got these issues or limitation. It can only check for source IP address of the incoming or outgoing packets. So in a packet, you can have source IP address, destination IP address, source port, destination port. But for standard ACL, we will only examine the source IP address. Okay, so this is quite limited. So now we have extended ACL. Extended ACL is more, has more features. It can examine source IP address. It can examine destination IP address. It can also examine the source port and destination port. So if you remember, port will indicate what service is it requesting. So if it's port 80, it's requesting for HTTP or HTTP protocol. If it's for port 21, it's for FTP. So the packet is going to request for some FTP services. So for port 23 is telnet. Okay, so for ports, now we can look at the ports of every single packet and then decide whether we want to allow the service or deny the service. So that's for extended ACL. Okay, this is one example of how an ACL will work. Okay, let's say an ACL has been configured on the router and is configured to examine every single packet. So if you remember, a packet will have a frame header which contains the MAC address, an IP header will contain the source and destination IP address, a TCP header will contain the source port and destination port, and the data that this packet is supposed to carry. So an ACL has been configured to permit web access to users from network A, but deny all other service to these network A users. Okay, let's look at this packet. Let's say this packet enter to the router. The router will first check which from niche network. So where does it look for this information? You look at the IP header. Okay, and where in the IP header you look at, because he's looking whether is it from which network, so he look at the source IP address. If the source IP address indicate that it's from network A, so network A, so we will permit web access. So I will check web access is actually port 80 in the destination port. So I will check the destination port. Is this user requesting for port 80 or not? Okay, so this will be checked here. Is it asking for port 80? If it yes, I will permit. Okay, how about if it is no, it's not port 80, let's say it's port 21 for FTP or port 23 for telnet. So for all other service, I will deny. So all other service, the packet will be dropped. Okay, so this is what will be done on every single packet. They will examine the packet header for the source IP address, and they will examine the TCP header for the destination port to see whether he's trying to connect to what service. This network A user is connecting to what service. And from there, he will decide whether to permit or deny. Okay, let's say we add another rules to say if for network B users, I will deny HTTP access but allow all other access. So this is the opposite of network A users. So if it's not from network B, not from network A, I will check is it from network B or not. So again, how do I check? Source IP address. So the second rules again will check for the source IP address. If it's from network B, I will check are they asking for port 80 services. So same thing, I will check the destination port again on the second using for these second rules. And if it's asking for port 80, which is HTTP service, do I allow? For net user B, it's denied. All other service, I will permit. Okay, so this is one simple example. Just two rules and using flowchart to explain to you how does the ACL works on a router. Which header do they check? Okay, in order to implement these two rules. Okay, let's look at the actual configuration of a standard ACL as compared to a extended ACL. So this is a standard ACL. You notice standard ACL only check for source IP address only. Okay, so where do we put the source IP address? We put here. together with a wildcard to tell the router check only for 192.168.30. The last number, no need to check. Okay, so I'm only checking for IP address for 192.168.30. If the packet comes in and it begins with 192.168.30, what do the router do? The router permit. Okay, this is an extended ACL. Okay, extended ACL, you need to configure more things because we can filter based on protocol, source and destination IP address, source and destination port. Okay, for example, I only look at TCP protocol. So permit TCP, and this means that only TCP packets are examined by this access control list statement. Okay, so only TCP packets are examined, and then we can look at source and destination IP address. Where do we put the source and destination IP address? Okay, this is the source IP. This is the wildcard. Okay, so this whole thing is a source that we are checking. Where's the destination? The destination is here. Destination IP. Okay, so what is the destination IP? It's any IP address, which means don't need to check for destination IP address. And this last thing, equal 80, is the destination port number. That means I'm only looking for destination port number 80. So destination port is checked here. So I'm only checking for TCP port 80. Okay, some of you may ask, where is the source port being checked? Okay, source port is not included here, which means you're telling the router no need to check for the source port. If you want to check for a source port, you insert it after the source IP address. This should be the source port number that you put in. After the source IP, you insert the source port. After the destination IP, you insert the destination port. In this case, port number are optional. If you don't put it in, like in this case, I don't put in the source port, this means that the router do not need to check for the source port. Okay, we also covered both number and name ACL. So if you remember, number ACL use a number to group the ACEs together. A name ACL use a name to group the ACEs together. So for number ACL, if it's between 1 to 99 or 1300 to 1999, it refers to a standard ACL. If it's from 100 to 199 or 2000 to 699, it refers to a extended ACL. For name ACL, we use a name to identify the ACL. It can be alphanumeric characters. We suggest to write all in capital letters, but it cannot contain space and punctuation. And you can add and delete between the ACL for name ACL. So name ACL normally is give a more meaningful to a ACL. It gives more meaning to a ACL. The next is on the placement of ACL. Extended ACL, if you remember, as close to the source as possible, so that you prevent undesirable traffic from traveling all the way to the destination. You want to drop the packet early, so as close to the source as possible. Extended ACL, as close to the destination as possible. Okay, why standard ACL place it as close to the destination as possible? Because for standard ACL, we can only specify the source. We can't specify the destination. For example, if we want to block all traffic from 10 to 30, so this is the source, this is the destination. Let's say we want to put the ACL here, but the ACL can only filter based on the source, which is 10. Then 10 cannot enter here, 10 cannot enter here, but 10 also cannot enter here, which is what we don't want. We only want it to be at 30. So in this case, it's filtering packet that we shouldn't filter. So if we want to put it as close to the destination as possible, we should put it here. So now 10 can enter here, but once it reaches here, it gets blocked. So my 10 still can access my 31 network. Okay, so for standard ACL, as close to the destination as possible. But for extended ACL, we should put it as close to the source as possible. For example, here, 11 is the source, 30 is the destination. We can apply the ACL here, or apply the ACL here. If we apply it here, that means the router need to route the packet and then go out and then drop the packet if it's going to 30. But if we apply it here, this means the router will drop the packet first before it routes the packet. So this will save the router from routing the packet and prevent any needless processing of the packet. So it helps the router to run faster.